In this video, we're going to go through the Section 5.2 activity. In this activity, we're going to do a problem that looks at furniture manufacturing. So our company makes dining room tables and chairs. A table requires 8 labor hours for assembling and 2 labor hours for finishing. A chair requires 2 labor hours for assembling and 1 labor hour for finishing. The maximum labor hours available per day for assembly and finishing are 400 and 120. 400 for assembling and 120 for finishing. Let X be the number of tables and Y be the number of chairs produced per day. Write an inequality that represents the number of labor hours available for assembly. So, looking at the problem, we know that a table requires 8 hours for assembly, and a chair requires 2 hours. And the maximum labor hours available for assembly are 400. So that means the most it can be is 400. So now I'm going to put this information into an inequality. X is going to be the number of tables and Y is going to be the number of chairs. So each table requires 8 hours. That means I multiply 8 by the number of tables. And each chair requires 2 hours. That means that I multiply 2 times the number of chairs that are made. And adding those two together is going to give me the total hours that is going to be spent on assembly. And I need that total to be less than or equal to 400. Now, to type less than or equal to, I'm just going to copy the symbol from later down here in the Word document and paste it. You can also, if you like, just use less than and then an equal to symbol on your keyboard, whatever is easiest. That needs to be less than or equal to 400. I could use all 400 hours, or I could use less than the maximum available, but I cannot use more than that. So that's my inequality for labor hours for assembly. I'm going to go through a similar process for finishing. A table requires 2 hours and a chair requires 1 hour. And then the maximum available is 120. So I'm going to multiply number of tables by 2. I'm going to multiply number of chairs by 1, which I don't need to put that 1 in front of Y. I can, but I don't need to. And then that needs to be less than or equal to 120 hours. So that's my inequality for labor hours. Question 3. It says, are any other inequalities needed? Well, kind of a natural inequality is that number of table and chairs cannot be negative, so it cannot be less than 0. So my correct answer here is that X needs to be greater than or equal to 0 and Y needs to be greater than or equal to 0. So I'm going to select answer choice D here. Question 4 says to graph these on the Desmos graphing calculator and list 3 points that satisfy the company's requirements. So I'm going to bring this up over here. So my inequalities, my first one is 8x plus 2y is, remember you can use less than and then the equal to symbol to put that line underneath, less than or equal to 400. And then my other inequality, 2x plus y, I'll use the keypad this time, less than or equal to 120. And then x must be greater than or equal to 0, and y must be greater than or equal to 0. So now I need to find where the graph is. So I'm going to zoom out here. And I can see that these are my inequalities. I have the red, the blue, I'm looking underneath those two and then above the green and purple. So what it makes is this four-sided shape. The boundaries are the y-axis going down here, the x-axis, and then this diagonal red line up until I hit the blue line, and then this diagonal blue line. It's where all 4 shaded areas are overlapping. It's a little hard to tell when there are so many colors, but that's going to be the area that I'm looking at. So the question is asking for 3 points that satisfy the company's requirements. So any 3 points in that area, I can pick some out here. Each box in my graph is 10. That's the scale. So for example, I can see a point here of 20, 20, or 2040, or 1080. Lots of possibilities here. So I'm just going to list some that I know are in this 4-sided shape. So let's see, we have like 250, 1080 is the point up here, and then 4010 is going to be this point right here. So I'll list those 3. Again, you can use a different 3 as long as it's in that shaded area. There are many possibilities. Obviously, we are somewhat limited because we do need to have a whole number. So it's not really infinite possibilities, but there are many possibilities. So those 3 are 3 possibilities. Again, you could find others. And then I'm going to paste the link or image of my graph.